Hello, this short video is over the quadratic formula and using it to solve quadratic equations and using the discriminant to determine how many solutions there are. So far we've learned different ways to solve a quadratic function. We've talked about graphing, factoring, finding the square roots, completing the square, and now we're learning the fifth way, which is using the quadratic formula. The quadratic formula helps us solve quadratic equations when other methods don't work. So factoring doesn't work, completing the square, solving by square root, graphing always works. So basically, if you're doing it by hand and the other methods don't work easily or don't work at all, you can always use the quadratic formula. So the quadratic formula is right here. This x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And remember, standard form of a quadratic equation is ax squared plus bx plus c. So once you determine what your a, b, and c are, you're taking that and plugging it into the formula to find your x values. Remember, your x values are your roots or your solutions. If you were to graph it, it tells you where the graph is crossing that x-axis. So look at this example. If we were going to solve for x in 2x squared minus 11x plus 13, my a is 2, my b is negative 11, and my c is 13. So using the formula, you plug in your a, b, and c, and then you go ahead and simplify. When you simplify, remember to use the order of operations. So you're doing everything under that square root first. And then also remember with square roots, you can have plus or minus. So you'll see here, once it's simplified, I have x equals 11 plus the square root of 17 divided by 4, or x equals negative 11, or excuse me, x equals 11 minus the square root of 17 divided by 4. So a square root member can have a plus or a minus. So let's work on an example together. Solve for x in x squared minus 5x minus 14. So the first thing we want to do is make sure our equation's in standard form. It is. It's equal to 0, so we're good. Now we're going to determine the values of a, b, and c. So my a is with my x squared. Remember, there's an imaginary coefficient there of 1. My b is with my x term, which is negative 5, and then my c, negative 14. So I'm now going to go ahead and take my a, b, and c and plug it into my formula. So negative b, and I'm just going to use the color black here. So b is negative, and then in here is a negative 5. Plus or minus my b again, so negative 5. Minus 4 times 1 times my c, negative 14, all over 2 times my a, which is 1. Now I'm going to go ahead and simplify. So I'm going to have x equals, well, a negative negative 5. Two negatives make a positive, so this turns into positive 5, plus or minus negative 5 squared. Negative 5 times negative 5 turns into a positive 25 minus 4 times 1 times negative 14. Excuse me. Well, 4 times 14 is 56. A negative and a negative makes a positive, so plus 56. All divided by 2 times 1, which is 2. So now let's go ahead and simplify under that square root. 25 plus 56 is 81. So I have x equals 5 plus or minus the square root of 81 all over 2. Well, this can keep being simplified. The square root of 81 is 9. So this turns into x equals 5 plus 9 all over 2, or x equals 5 minus 9 over 2. And you should notice we can now simplify that even one step further. 5 plus 9 is 14 divided by 2. So this gives us 7, or 5 minus 9, which is negative 4, divided by 2 would be negative 2. So my two solutions are x equals 7 or x equals negative 2. Now let's talk about the discriminant. The discriminant is the part that is inside the radical. So it's only talking about that b squared minus 4ac. That's the only part it's referring to. And the importance of this is by determining what b squared minus 4ac is, we can determine how many roots or how many solutions a quadratic equation is going to have. This chart, which is also on page 570 in your book, tells you. So if you solve b squared minus 4ac and you get a positive number, so basically it's greater than 0, you are going to have two real solutions. Basically, if you graphed it, your graph is going through the x-axis twice. If your discriminant, or b squared minus 4ac equals 0, this tells us there's one real solution, and if you graphed it, your graph would be sitting on the x-axis, so it would only cross through it once, or touch it, I guess, once. Lastly, b squared minus 4ac, if you get that and it's less than 0, you have no real solution. So if you graphed it, your graph would not be going through the x-axis. And if you think about it, this makes sense because the discriminant, the b squared minus 4ac, is the part under the square root. You can't have or you can't take the negative square root of a number and get a real number. Remember, we talked about this, it turns into an imaginary number. So that makes sense that there is no real solution. All right, so let's go ahead and let's look at some examples. So how many roots does each have? And we're going to use that discriminant to determine this. So x squared minus 4x equals 2. Well, right away, I notice this is not in standard form. Standard form equals 0. So I'm going to subtract 2 from both sides and write this as x squared minus 4x minus 2 equals 0. So now I can go ahead and I can use my b squared minus 4ac, where my a right here is 1, my b is negative 4, and my c is negative 2. So if I plug that into the discriminant, so b squared, so negative 4 squared minus 4 times 1 times negative 2. Let's see what we get here. Well, negative 4 squared is 16. Negative 4 times 1 times negative 2 would be a positive 8. Well, 16 plus 8 is 24. So I get a value greater than 0. So in this case, b squared minus 4ac is greater than 0. So there would be two real solutions. So I'll put 2 real. Okay, let's look at example 2. X squared minus 2x plus 1. My a in this case is 1. My b is with that x, which is negative 2. And my c is 1. So again, let's plug it into this discriminant here. So b squared, well, b is negative 2, so be negative 2 squared minus 4 times 1 times my c, which is 1. So all I'm doing is evaluating, plugging those into the formula. Well, negative 2 squared turns into positive 4 minus 4 times 1, which is 4. Well, 4 minus 4 is 0. So in this case, there would be, down here, one real solution. So this would be 1 real. Now, mind you, 0 is not the solution to this. I would have to go ahead and I would have to solve using the entire quadratic function or quadratic formula, or I could solve using one of my other methods to determine what the one real answer would be. This is just a way to tell us how many solutions there should be. So if you would solve and you, let's say for Number one, if you only got one answer, you would know you did something wrong because the discriminant tells us there has to be two real solutions. So this is just a quick way to determine how many solutions there are or how many times your graph is crossing that x-axis. It's not telling you what those solutions are. So just to be clear there. So lastly, x squared plus 3x equals -4. Again, this one does not equal 0, so it's not in standard form. So let's go ahead and add 4 to both sides to get it into standard form. So this would be x squared plus 3x plus 4 equals 0. So now I know my a equals 1, b is 3, and my c is 4. So go ahead, let's plug it in. So this would be 3 squared minus 4 times 1 times 4. Now let's simplify. 3 squared is 9, minus 4 times 1 times 4, which is 16. Well, 9 minus 16 is -7. This is less than 0, so this would be a no real solution, or if I graphed it, it would not go through my x-axis. So again, the quadratic formula is just another way to help you to solve quadratic equations for x, and then the discriminant tells you how many solutions. If you have questions, you need help, please don't hesitate to reach out to your teacher. See you next time.